this is going to be a nice problem for us. They give us the graph of f, and they even tell us what the area of that region R is. And then they say g is the integral of f. So if I have that function, I want to find those values. I wrote that function down just like a normal algebra equation. If I give you g of x equals something, and then if they say find g of those numbers, you just simply take those numbers and plug them in for x. So we're going to do the integral between 0 and -6, 0 and 4, and 0 and 6. So usually when it's not least to greatest, like when you go bottom to top and they're switched around like that, I always switch them back. And when you switch them back, that just allows us to put a negative in front right there. And then remember your number representation of your integral is the area. So to figure out this integral answer, that's the area of this graph, of this f graph between -6 and 0, which they flat out told us was equal to 12. So that integral is 12. And because I had to switch those numbers around, that made it a -12. And then we're going to do the integral between 0 and 4 of f of t. So you're going to do between 0 and 4, that's the area between the curve and the x-axis. So that's this triangle right here. So you just got to go 1/2 times the base, which is 4, times the height, which is 2. And then you get that area of 4 right there for the integral. And it's positive because it's above the x-axis. When you do g of 6, that's going to be the area between 0 and 6 of this f of t graph. We already did the area between 0 and 4, and now you're just going to add on the area between 4 and 6. Now, since this graph goes, so there's the 4 right there. That's between 0 and 4. And then I subtracted it because this graph goes below the x-axis there. So that would have a negative integral value there. So you're just talking this triangle, 1/2 times the base, which is 2, times the height, which is 1. You're just talking this little triangle in this region right here, and then subtract it out since it went below the x-axis. This was a no calculator problem, very doable without the calculator. Okay, so part B is still sticking with this function. It says this g of x is equal to the integral of f, and then we want to find where g has a critical point. So we know critical points is where these derivatives is equal to 0. So I want to figure out where g prime is equal to 0. Now, since they gave us g is the integral of f, we know when we take the derivative that the derivative of the integral is that original function. So that's a big thing right there. That's probably worth a point right there if you just know that g prime is equal to f. And then the critical point is where g prime is equal to 0. So since g prime is equal to f, if I want to know where the derivative is equal to 0, that's where the f is equal to 0. So you're just looking at this f graph and thinking, where does it have a 0? Where does it cross the x-axis right there? And so that's at x equals 4. So knowing that g prime, the derivative of that integral is equal to f, so g prime is equal to f, and that x is equal to 4 right there. So technically a critical point is like where the derivative is 0 or undefined. But this is the derivative of g. So like this is defined everywhere. I know like if that graph would have corner points and stuff like that, like its derivative would be undefined. But as long as you have points everywhere, like this graph is defined everywhere. And that is the graph of f, which is also the graph of g prime right there. So just take that derivative, figure out where it's equal to 0, look at the graph of that. Where is it cross the x-axis? Okay, letter C gives us a new function. And then find these values right here. So when it gives me h of x equals something, and I want to find h of 6, the first part of this is just taking that 6, plugging it in for x right there. So I'm going to do the integral between -6 and 6 of f prime of t. Now, when this is not f prime, this is the graph of f. So when you integrate f prime, you're going to actually integrate that. When you integrate f prime, you get f of t, and then you have your numbers attached. So just plug in top minus bottom, like when we normally do definite integrals, and then f of 6 minus f of -6, you can get those from the graph there. So f of 6, they told us was -1, and then f of -6, they told us was the 0.5. So I just subtract those numbers to get -1.5. And then when you want to do h prime, so if your h is the integral of f prime, I like to do these little boxes right here because I can just kind of go straight to it. So h is the integral of f prime. So when I take the derivative of h, I get h prime. So when I take the derivative of that, the derivative of the integral is just the inside function, which means h prime is equal to f prime. And if I take the derivative again, that means a double prime is equal to f double prime. So those two things is what I'm using for these last two parts there. So h prime is equivalent to f prime. So when they're asking me for h prime of 6, that's the same thing as f prime of 6. Our number representation of the derivative is the slope of the curve. So f prime of 6, this is the graph of f. So if I want to go from f to f prime, I know the derivative means slope. I just want to find the slope of that given f graph at x equals 6. So that's why they made that linear for us. So you could probably a little bit quicker if you just go from this nice point to this nice point. We went, or you could count rise over run. We went down 2 over 4, which reduces to negative 1/2. Or if you feel comfortable, you want to use your slope formula, just subtract the y's on the top, x's on the bottom, take a couple points on that line, and then use your slope formula to get that negative 1/2 there. And then we talked about how h double prime is f double prime. So h double prime of 6 is f double prime of 6. So they're saying at 6, what is the second derivative equal to? Now at 6, I know that this is a line. Okay, I could find the equation if I want to, but I don't have to. I know the f right here at 6 is a linear function. So like let's just say it's y equals mx plus b. All right, so if I will take the second derivative of any line, if I take the first derivative of a line, it's just the slope of that line, which is a number. And then if I take the derivative of a number, I'm always going to get 0 for that second derivative right there. That's why a line, you're not talking, it has like concavity. So you're not talking about a positive or negative second derivative being concave up or concave down. So imagine if I just had a normal like y equals like negative 1/2 x plus 2. The first derivative would be negative 1/2, and then the second derivative would be the just equal to 0 right there because you're doing the derivative of a number, and so you're just going to get 0 for that. So a nice little problem. You got the integrals with the area stuff. You got some derivative stuff there. You're using your fundamental theorem of calculus and everything. So nice little problem there, but we could be real strong at that and try and get all of our points on that particular problem and understand and let me know if you have any questions there. Tiramisu.